Bruce, Ken, and I are profoundly delighted and honored to introduce a man who really needs no introduction at all in this audience, Professor William Sharpe. We all know the foundational role Bill Sharpe has played in the development of quantitative finance and the growth of risk management as a sophisticated professional discipline, and his contributions to economics as a whole. Bruce and Ken, I think, would each like to say a few words about the significance of Bill's career and work and why we are honoring him here today. Bruce? Or Ken?
Thanks, Chris. Bill Sharpe was still a graduate student at UCLA when he began his work on what became known as the capital asset pricing model, work for which he later received a Nobel Prize in economics. Bill has been associated with Stanford University since 1970 and is currently Professor Emeritus at the Graduate School of Business. Throughout his career, Bill has understood the importance of drawing out the practical implications of academic research. His early work introduced the idea that investors could find success in holding a market portfolio, an insight that led to the development of index funds. In fact, Bill worked with Wells Fargo to create one of the world's first index funds. Over the years, Bill's research has touched on many areas of finance. He's published important research on portfolio theory, capital markets, and asset allocation. He's developed a binomial asset pricing model and authored numerous articles in academic and professional journals and 7 books, including a very highly regarded textbook in finance. Bill's work on retirement planning led him to co-found Financial Engines in 1996. It was one of the first independent online investment advice platforms, and today it provides advice to employees of many of the nation's largest companies. Bill has said that he likes to pursue, quote, useful theory, and his activity bears that out. Well, we like useful theory too. In fact, it's the very essence of the Wharton-Jacobs Levy Prize, which recognizes not just outstanding theory, but theory that leads to important innovations in the practice of finance. Bill's work on returns-based style analysis fits that description to a T.
The Wharton-Jacobs Levy Prize for Quantitative Financial Innovation is awarded biannually and recognizes outstanding quantitative research that has contributed to an important innovation in the practice of finance. It is our hope that the recipients will, over time, constitute an elite group of scholars and practitioners who have had a transformative impact on finance. There can be no doubt that the recipient of today's award, Bill Sharpe, is among the most elite scholars of our profession. In his long career, he has contributed many important insights to the practice of finance, notably the capital asset pricing model, which is part of the foundation of modern portfolio theory, and the Sharpe ratio, perhaps the most recognized measure of risk-adjusted returns. By the way, he did not coin the latter term. He prefers the reward to variability ratio, but I guess the Sharpe ratio simply sounds better to his many admirers. Today, in awarding the Wharton-Jacobs Levy Prize to Bill, we recognize his work on returns-based style analysis, which grew out of consulting work he did with Frank Russell for pension funds in the 1980s. In order to recommend asset allocations for large funds, some of which had as many as 100 managers holding thousands of securities, he needed to know what asset characteristics, nowadays we would say factors, they were exposed to. Using a factor model and historical return patterns, Bill showed how to map a fund's exposures to a wide variety of investing styles, from large cap growth stocks to foreign stocks, to treasury bills. His innovation made style analysis widely and economically available, not only to pension funds and other institutional investors, but also to retail mutual fund investors. Bill, we are proud to present the Wharton-Jacobs Levy Prize to you. Your scholarly work is distinctive and has had a profound impact on the financial world. Thank you for your many contributions and a hearty congratulations. Bill, please join us at this time.
Thank you.
Congratulations.
Thank you very much. Thank you.
We have at this time the honor of presenting the Wharton-Jacobs Levy Prize Medal to Bill.
Wow, beautiful. Gorgeous. I'm going to put it on.
Oh, sure. Be my guest.
See, I've got it and you don't, so I'm going to try to put it on. All right.
Wow.
Thank you.
Congratulations. Party congratulations.
Thank you, Ken, Bruce, Chris. It is indeed an honor and a great pleasure to be here to receive the prize, to see many old friends, and the word old is emphasized. You know who you are. I noted that the title of the session was a reprise. I'm using the French pronunciation. A reprise of work in style analysis. And listening to Joseph's fabulous presentation and to Bruce and Ken's introduction, I see now why it's a reprise, because you've kind of heard about it. So I think what I'll do, if with your indulgence, is engage in a little bit of a nostalgia trip and show you some pictures from the early years of style analysis and say just a little bit more about it. There is the model, and we had been doing factor models in finance for some while. And the genesis of how this all came about, as was mentioned, my wife Kathy, who's here, and I set up a small research and consulting group in conjunction initially with the Frank Russell Company to work with some of their large multi-managed funds, General Motors, State of Washington, et cetera. Very much the sort of situation that was described by Joseph. And the idea was we were going to develop techniques that would be helpful to the manager of the fund, and the professional inside the company or the state who was in charge of the pension fund with all these many external and some internal managers. And so we set up and we hired some employees, and then we decided, okay, how are we going to do this? And we found out, as you've heard, that one of these funds would typically have 80 outside managers, and each of the managers would have 100 or 200 securities. And there was just no way we were going to be able to look at each of the managers and each of the portfolios of each of the managers. And so we had to figure out something to do to figure out just where the overall fund exposures were, so we could then ask, well, would they perhaps be better off with, in some sense, with a different set of exposures, Bs in this case, and how did they do relative to their exposures, the kinds of things you've already heard about. So we said, not a problem. Let's see, there's a dependent variable and a bunch of independent variables. That's a regression equation, no problem. So we got some indices, and initially just a few, a value stock index and a growth stock index, a medium and a small first time round. And these were Russell indices initially. And we convinced ourselves, yes, these things did not move in lockstep, because in regression, as many of you know, if the things you're using as explanatory variables all move together, and there's no way you're going to be able to sort out who's doing what to whom. And so this was just an early, this is circa what? Well, this is from the second. There were two papers. There was an 88 paper that I think was referenced, and then a 92 paper, which was based on a 1990 presentation, University of Virginia. So most of these are from the 92 paper, but some are from the earlier. I may indeed be able to figure out which. This is from the later paper, but the same, it's just illustrative of the fact that, yes, Virginia sometimes value do better than growth, and vice versa, et cetera. They differ. There's enough variation, this is year to year, in the relative performances of these particular indices to provide a reasonable, if you will, you can think of it as a basis if you're used to that terminology. So here was our first attempt, or a reconstruction perhaps, of the first attempt, in which we did an analysis. The fund here was a mutual fund, trustees commingled fund, which was actually a Vanguard fund. Times were different then. And so I did a regression, and I got wonderful results. They had a minus 69% exposure to intermediate bonds, 109% exposure to value stocks, and then the damn things didn't even add to 100. So I said, okay, I got a great fit, 95% fit. Okay, well, that's easy. I can figure out, I know how to do a regression where I could strain the coefficients so they add to 100. So I did that, and sure enough, they added to 100. And now the intermediate bond exposure just fell to minus 68%. And the medium stocks is down to minus 43%, and so on and so forth. So basically garbage. At which point, Kathy may remember, we were sitting around the office saying, okay, what do we do now? And then I thought a little bit, and I thought, well, there's this thing called quadratic programming that solves an optimization problem where the objective function is a quadratic, blah, blah, blah. I've been doing that. I'd even written an algorithm or two to solve that kind of problem. Maybe if we just tell the optimizer, please will you do this, but look, we know they don't have any short positions at this particular fund. So no coefficients less than 0, and we know, of course, they don't have more than 100% in anything, so nothing greater than 100. In other words, and in some sense, philosophically, this is a sort of a Bayesian analysis. You have some prior information. You bring that together with the data you have at hand, and from that, you do an analysis. And we did, and voila! This is a true story. It's probably one of the better true stories from the era, but 65, I can't read it very well, 65% value and 30% small, blah, blah. And then we went to people who knew the fund and said, does this make sense? And yeah, that makes a lot of sense. That's basically the whole story. You know? You know? And I suppose I should take questions, but I'll show you some more pictures. I said I'd done some quadratic programming algorithms. This is one that I published in 87, I guess. It's a very simple gradient method, very simple programs. And it turned out to be really fast. And I'll just tell you one story. A friend of mine who, very, very smart guy, worked for a large firm which will remain nameless. He came by Stanford and said, look, I'm trying to do style analysis using your algorithm, and it's great. It gives wonderful results, but boy, it takes a long time to solve a problem. And I said, and this is, remember, 87, real computers, and said, how long does it take? I said, 3, 4, 5 minutes. So that's funny. For me, it's 10 seconds. And so we chatted, and I said, well, this is a kind of algorithm that just keeps going until it gets close enough and then stops. And I said, well, what's your tolerance parameter? And I said something like 10 to the minus 20 or something. And I said, why don't you try whatever I was using? And then it worked fine. Okay, so this is the December 88 And the initial tests we did of the efficacy and applications of this were to the managers in the portfolios of our clients, the General Motors, et cetera. So these are the kinds of funds Joseph was talking about, funds managed by external managers for in various large funds. Importantly, we had large value, large growth, and small, just 3 partitions of the equity market, and then we had foreign bonds and stocks and whatever. And this is a graph of the R-squared values. Now, I say in sample, and that's important. We literally took, say, 60 months, did the style analysis, maximized how well it fit, and then saw how well it fit. So that's in sample, and remember that. I'll emphasize why. And that was for 388 of these accounts, and the results were pretty good. You know, a lot of them were in the 90% more explained, variation explained by the fitted asset allocation, let's call it. So then later we did a lot of research with Barra, trying different combinations of indices on a very large database of mutual fund returns that we found a guy in Texas had collected. And we experimented with how fine a partition could you use, say, in the equity market and still get meaningful results, not overdo. And the thing that I would emphasize here is we ended up with large cap value, large cap growth, medium cap, and small cap. Subsequently, we found you could divide the medium cap into growth and value. But if you did that with small, you just got garbage. It just didn't make any sense. Now, that's then. Now, I have no notion. So here's an interesting thing where we take the 60-month window and we move it forward through time. So each of these is style analysis results as of a date with 60 prior months. And there's a lot of overlap, of course. But this shows at least that trustees pretty much stayed to a particular asset allocation. It didn't change much. And that in itself turns out to be interesting. Now, some of you will remember Fidelity Magellan was the darling of the mutual fund industry in this era. And so we thought it'd be interesting to look at this. And during this period, which was 85 to 89, it turned out that Peter Lynch, the manager, had no exposure to value, at least as we measured, and then had quite a bit to medium and small. And the pie chart, which is hard to read, said, in sample at least, this really explained what was going on in that fund. I'm not saying there wasn't an alpha, but in terms of the asset allocation. But if you look at the rolling analysis, what you see is during this period, he started with a substantial exposure to small stocks. That's the top left splotch, and then moved sort of necessity probably because money was pouring in to much less exposure to small stocks. That seemed to be interesting, and it was interesting that the analysis turned that up, and it turned out to be true, fortunately. I'm going to show you now very briefly some of the analysis we did of the mutual funds. We took sets, in this case just 4 utility funds, so classified by somebody else, did the style analysis, and looked at the in-sample R-squared. And this was interesting because the utility funds turned out, although they held equities, to have a serious exposure to the fixed income market, which, if you think about regulated utilities, especially in that era, made a lot of sense. I sometimes said, and I actually found it in one of my articles, all of this is predicated on the duck theorem, which is if it looks like a duck and talks like a duck, it's probably a duck. And sure enough, so here's some growth equity funds. What do you see? Growth. Pretty good in sample. And by the way, each of these graphs is the average of the results for the funds in the group. So this is not a regression using a composite of all the funds. So think of it as this way. The typical fund, and then in this case there are 161, look like this. These are all from the 92 article. Growth in income, you can't read this from the back, so trust me, it's wonderful. Small stock, balanced fund. Look, these are balanced funds. Guess what? They've got exposure to everything. And for some reason, the pie chart didn't work, but it was 89%. Bond high quality works for bonds. Convertible bonds, pretty sensible, pretty good R squared. Now, here's a kind of an interesting situation. This is Fidelity Magellan from 85.12 for 60 months versus its chosen benchmark, which was probably the S&P 500, I've forgotten. And it's sort of a cumulative, so when it goes up, they beat the benchmark. When it goes down, they were beaten by it. And you see, it's okay, but it's nothing particularly to write home about. But if you compare it with their style, which is, you recall, perhaps, is value and small, gangbusters. Now, you usually see the opposite. The performance relative to the benchmark is usually good, especially if they get to choose the benchmark after the fact, as some do. But when you do the style analysis, it goes away. But I wanted to show you this because it was an exception. So this is a distribution of the R squared values in sample for that sample of 636 mutual funds. And you'll see, you can't read it perhaps, but the mean was minus 0.074% per month, okay? And these are mutual funds, so these are net of expenses. So you're looking at somewhere around a net alpha, to use that terminology, of about minus 1%. But in any 60-month period, a huge distribution. And guess which ones are going to take out ads at the end of the period? Okay, I just want to say a little bit about performance analysis and out of sample. The idea, and I feel very strongly about this, some people cut it a little bit, but if you're looking at performance, basically what I did was do the style analysis using 60 months ending, let's say, through December. Okay, so you have 60 months, including returns during December. And then compare the returns in February, T+2, with the returns on that particular style mix in February. And so the idea is this is operational. When you finally get your style analysis done in the middle of January, you could say, do I want to keep this manager or maybe just invest in ETFs or index funds with that style for February? And then at the end of February, you say, well, which would have done better and how much? So you compare each month the actual performance with a passive alternative with the historic style chosen well in advance. And then you roll that. And over the years, that's what we did when we had the firm in different incarnations and then up to a while ago. And you can compute what amounts to an R squared to see how well the style fit out of sample. In other words, how well you could explain what actually happened by what the manager had at least been doing on average in a prior period. Now, there's some subtleties. Typically, we use some exponential smoothing in the style analysis, and there's some other things you can do. But this is really, this passes the academic test of are you really out of sample here, folks? There are the issues. How many months do you use for the prior style? Do you exponentially weight, and if so, what's the weighting? Did some experiments with that and ended up more or less with 60 months or maybe whatever you've got in terms of history. exponential weighting, I think it turned out that the efficacy was pretty much the same, whether you used a 0.99 for each month relative to the subsequent month or whatever. So, I mean, it was not terribly sensitive. It helped a little, and in the course of doing this in practice with some funds for a while, many years, we tended to just use one coefficient for the exponential weighting for everybody. And that's helped a little. It didn't make a huge difference. I'll just show you a couple of slides. I've kept the identity of the fund, in this case, pension fund, secret to protect the guilty. But here was, what you could do for each of the managers. You could do the style analysis, you could do the performance analysis, you could aggregate into domestic equity managers, you could aggregate to the whole fund, et cetera, et cetera. I think for this particular fund, we ended up producing every quarter something like 500 graphs and tables, all of which I'm sure they read. But here was aggregated up from the manager style analysis, the overall exposures as we measured them of the fund to these asset classes, which in this case includes real estate, venture capital, and buyout, where style analysis doesn't work at all. So in those, we just said, we'll compare you straight off with an index, because as you know, valuations for those private classes are really squirrely, and style analysis, at least as I did it, Michael who's here, might have some ideas on that, but just didn't help. So that was kind of what we'd intended to do all along, help the manager of the pension fund get his or her arms around just where the money was, at least in an economic sense. Here is, for that same fund, a compound return, so when it goes up, they beat the style. In this case, the yellow is the style. It's all out of sample. And the blue is the fund. And as you see, most of what was going on with the fund during this period was attributable to style. They beat it for a while and then lost it and ended up a little bit below it. And that's kind of interesting information, if not for the pension fund manager, at least for the board. This is cumulative of this takes out the impact of cash flows in and out of the fund and is in some sense a cleaner indicator. And then finally, this is an aggregate, in this case, from the bottom of all the domestic equity managers in this fund, of which there were many. And it's basically, if you want the residual or the alpha, month by month, out of sample. And so when it's positive, they beat their historic style. When it's negative, they were beaten. And what you see is there's some good months and bad months. And then down at the bottom, the percentage due to style for this particular fund. This is an aggregate of a number of external equity managers, 99.1%. And you see this when you do this kind of analysis with these large multi-managed funds. Almost everything that happens is due to the styles of the managers. Remarkably little to any alphas, et cetera. And again, this is clean. I hope my academic colleagues will agree that it really is out of sample. And you can do t-tests. You can look at the mean and the standard deviation, do a t-statistic. The last thing is a selection percentile. It says something like what percentile of managers with absolutely no skill whatsoever taking the same amount of non-asset risk would end up with an overall average alpha of this amount, which in this case was, it was at 50, this is the percentile, right in the middle of the distribution of a random number of managers with no talent whatsoever, if I can put it in pejorative. So that's the story. Well, at the time we did this and did the publications, and some others, including some in this room, started doing commercial services, the Morningstar people just, and many others, including our initial partners, some of the people at Frank Russell, said, no, 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 this doesn't make any sense. You need to get in there and look at the securities in the manager portfolios. And so we had just called it style analysis, and so it became known as returns-based style analysis to differentiate it from holdings-based. That is, you look at the holdings, and you say, how much have you got in stocks that we call value, and how much do you have in stocks that we call growth? And you can imagine that in some cases that's going to be better. You can imagine in some cases it's going to be worse because it doesn't allow gradations. There are boxes, and if you're in the box, you're treated the same as everybody else in the box, so you can't get the gradations that you might pick up with style analysis. So here's what Morningstar said as of a couple of weeks ago. Returns-based is more widely used among financial professionals. Notice it didn't say among academics, as you heard from Joseph, because the input data, monthly returns that's their term. No, I was taught data's plural, sorry, is widely available. And it says Morningstar has long been a proponent of holdings-based, but recognizes there may be situations where returns-based can also be helpful. And by the way, we'll sell you either one. And ideally, I like the last line, I like a lot. Ideally, practitioners should use both approaches, and I have no problem with that. So that's a bit of history, some graphs from yesteryear, and I'd be delighted to answer any questions.
Great. Thanks, Bill. Okay, questions for Bill?
Hi, Rick Nelson, Syzygy Advisors. I'm curious, kind of Einstein later in his career, he had this goal of the unified field theory and kept progressing towards that, never quite achieved it. But is there something that you'd like to solve, the puzzle that's been out there that you'd like to still come up with the answer to it?
Yes, it's far short of the unified field theory. I've given you now everything I know about the unified field theory. It's named. What I'm focusing on now, you heard that I devoted some time to the accumulation phase that ordinary people go through trying to prepare for retirement. All my research and work now is focused on the decumulation phase. Prototypical problem, you've retired, you and your partner, and you've got a 401k, you've got maybe a house, you've got Social Security. What do you do now? And so that's the problem. And I'm doing it with 100,000 scenario matrices with 50 years in actuarial data and Lord knows what, and a multi-period, a very simple multi-period, let's call it asset pricing model. And for those of you who know these terms, it's a pricing kernel as opposed to a mean variance structure. But that allows me to price out virtually anything in this simulation world. So that's what I've been doing, and I've been trying to get my arms around the problem, some of the more important and more popular quote solutions to the problem. What are the properties of the 4% rule versus constant percentage payout versus some other things that are a little bit more novel, I think. But do I expect to get the solution? Absolutely not. Nor, I believe, will anyone else. It's just it's a nasty problem. It's the nastiest problem I've ever tried to, if not solve, at least make some progress on. But as we all know, it's a hugely important problem. So that's, if I had my druthers and I could make some serious contributions in that area. I'm trying, but no promises. Thanks.
Michael Markov. More than 20, around 92, we were the first ones to develop a style analysis product based on Bill Sharpe's theory and with Bill's blessing, we went and tried to convince people to try to use it. But as Bill said, the industry was up in arms. Pretty much the entire industry was up in arms against this concept. I don't know, just give you a couple minutes. It's you know, we've been doing this for 20 years, so it's maybe interesting for the audience. You know, John Christopherson and Russell unleashed you know, a campaign and even publishing papers against it, and consultants didn't embrace it. Obviously, it took a lot of their fees. Obviously, managers didn't want it, and plan sponsors couldn't believe this, that you can, by taking returns and by just taking only fund returns, you can actually figure out what the manager does and whether they add any value. So there was a very hard battle to actually for the industry to embrace, and we're, you know, very glad that we have now even Morningstar is embracing it and selling their own version. But it was an uphill battle at that time. It started with pension funds.
Thanks, Michael. Yeah, Michael, as he said, they were the very first to program it and make it available commercially.
Just I'm saying the style analysis has its issues. You know, it's like when you release constraints, you have all of a sudden, you know, you have to know how to deal with this. You know, when you release constraints, when you're dealing with things like private equity, how you deal with this. So it has issues, and you know, it has some additional things to, you know, algorithms to work with this. But you know, that's doable, and it's obviously.
Thanks, Mike.
Okay.
Yeah, there's an art to it as well, but you have to be very careful that you really are out of sample in every sense of the term, because there's always the danger. Everybody who does statistics of any kind knows there's a danger, especially if you're going to try to act on something. You need to be sure the statistics you're using are statistics you could have acted on, and all that was in your back test if you do a back test, but that's another story.
Bill,
Indeed.
I've always liked your quadratic programming approach, and my students have loved it for 25 years, I suppose. I still use some of your slides there. On style analysis, I wanted to ask, what are frontiers yet? If you don't have, none of us have infinite time, and you're working on the important retirement issues, but in the style area, are there like any issues raised by the global markets or any dynamic portfolio changes in exposures, or what are the most interesting issues in that area that you would say now?
Yeah, the honest answer, Doug, thanks, is that I don't know. I applied the method where the couple, you know, the one I showed you was the last standing fund that I worked with until we both decided there were other things to do. So I don't really know. I haven't experimented. I haven't even done a style analysis now for almost 5 years, and I haven't experimented with different asset class palettes. We sometimes call them palettes, done out of sample tests, and I'm not sure. Well, obviously Joseph's been doing this, and so I'm anxious to chat with him and read his paper, but I don't honestly know. And of course, you have to be careful because sometimes, you know, in a period of maybe even a few years, a particular variable won't manifest itself with enough variation, or in particular enough uncorrelated variation to enable you to parse out what kinds of exposures people might have to that variable. So I mean, there are a lot of practical problems. I guess my observation would be, without doing much of anything, and I know Michael and his partner have been doing quite a bit of this over the years, without really changing things very much, it continued to get these astounding out-of-sample R-squareds, at least at the overall pension fund portfolio level.
While I have the mic, I want to say one more thing, which is I was a PhD student of Bill's in 1976, I think it was, when he put on the midterm exam what became the binomial option pricing model. And John Cox, I know, tried to get him to co-author that article with him, but it was on our midterm exam. Anyway, it was cool.
I want you to know this was not pre-planned, and B, yes, I will pay for dinner tonight. I think, unless somebody has a pressing question, I know you have other things to do. Thank you all so much, and thanks to the Institute.